In this video, we will look into Booth's algorithm for 2's complement multiplication. The algorithm is given in the pictorial form as a flowchart in page number 368. So this is the algorithm. So first you will start the algorithm, initialization of many registers, register A, Q minus 1, M, Q, and there is a counting. Initially it's set to N. N is the number of bits of the multiplier. Okay, now we will check the bits of Q0 and Q minus 1. So this is the 0th position, bit position, and Q minus 1. This is a single bit register we will be maintaining. Okay, while tracing I will explain this register. So we will check the register Q 0th bit, the position 0, least significant bit. If both the bits, either this will be 0 or 1, combination of 0 or 1. If the bits are 0 and 1, so 0 means Q0, this is Q minus 1. If the combination is 0 and 1, you will do this step. If the combination is 1 and 0, 1 means Q0 is 1, this 0 means Q minus 1 is 0. If the bits are 1 and 0, you will subtract A minus M. And after this, there is an arithmetic shift to the right by 1 bit. Okay, so this arithmetic shift, when I tracing, I will explain the arithmetic shift. Then count will be decremented by 1. And now we will check. Is it the count is 0? Then you will stop the tracing or algorithm. It's over. If the count is not 0, you go back and then repeat this loop. Checking, doing addition or subtraction, arithmetic shift, and then decrement the count and continue the loop. So in this way it will be executed quite a few times until the count value becomes 0. So this is the idea of this algorithm. We will trace with one example, multiplication of 2's complement. So when I say 2's complement, it is a signed integer. So you can multiply positive with negative or negative and negative, positive and positive. It's a signed number. 2's complement is for the signed number. The algorithm name is Booth's algorithm. Okay. So let's look into one example. Let's assume that multiplicand is that is equal to, I'm going to keep it in a register, say M, and that is equal to 1 0 1 1, and then multiplier, which will be in register Q. Let's assume that multiplier is 1 1 0 1. Let's assume this example. So we will be having certain registers here. So what are the registers we are going to have? A, and then Q, and then Q minus 1, and then M. Okay, let's assume you have register A, and then Q minus, this is Q minus 1 is a 1 bit register. It will contain only 1 bit. And then M. Okay, I already mentioned that M is 1 0 1 1. Q is initially 0. Q minus 1 is initially 0. Q is the multiplier 1 1 0 1. And A, it's initially 0. So this is the initialization. So as we have 4 bits in the multiplier, you will be doing it for 4 times. Fine. So now let's move on to the first iteration. So this is initialization. So let's do first iteration. In first iteration, you will be checking the bits of Q 0 and Q minus 1. Okay, this is the thing. Q0 is this bit, 0th bit, 0th position. So this is 0th position, position 1, position 2, position 3. This is 0th position. This is Q0. Okay, this is Q minus 1. If the bit combination is 0, 1 means you do addition. Now it is 1, 0. See, 1, 0. If it is 1, 0, you do the subtraction. What is the subtraction here? A equal, let's write it, A equal A minus M. So what is your A? 0, 0, 0, 0. What is your M? 1, 0, 1, 1. When you do these A minus 1, do you remember the subtraction we saw how to do in the previous examples, previous topics? You take the 2's complement and add with the this first number, is it? So take the 2's complement. So 1, 0, 1, 1. First you take the 1's complement. 0, 1, 0, 0. Add a 1. You will get 0, 1, 0, 1. So this one you add it with A. So as of course it's 0. When you add the with the 0, you get the same number. 0, 1, 0, 1. So that is the A value. So now I know the A value 0, 1, 0, 1. Q is as it is, and then Q minus 1 as it is, and then M. So let me write all those things. Q and then M. Now arithmetic shift. What I am going to shift A, Q and Q minus 1 to the right side. So this is your right side. So these three only. M, don't touch the M. So M is as it is. So you will be shifting A, Q and then Q minus 1 to the right side. When you shift to the right side, you will lose this most significant bit. The last bit will be gone. Okay, but here I am following arithmetic shift. What is the arithmetic shift is, you move to the right side, is it? So you keep this bit and shift it. So what does it mean? Let me explain you. The last bit, the most significant bit is 0. You keep it. And then you shift to the right side. So this one will come here, 1 will come here, 0 will come here. This one comes here, and this one, and this one, and this 0. And this one goes here. And this 0 gone. Don't touch the M. M is always 0. Okay then. Now count is in decrement. Every time you decrement the count, the count was 4 and now count is equal to 3. Count is now equal to 3. Initialization, count was equal to 4. 4 bits in the multiplier. Okay then. So count is equal to 3. Fine. You continue the next iteration. Okay, let's continue. Now again I go back to the loop and I'm checking Q0 and Q minus 1. So here it is, Q0, Q minus 1. What is the combination? 0, 1. So if it is 0, 1, I add the A equal A plus M. So let me do all those things. A equal A plus M. What is your A? You just got that 1, 0. 0, 0, 1, 0. It's A. M. I'm adding it. 1, 0, 1, 1. When you add it, you get a 1, you get a 0, you get a 1, you get a 1. So the answer is 1, 1, 0, 1. So let me write it. 1, 1, 0, 1. Q. Let me write the Q as it is. Q minus 1. And like this. Now I'm going to do the arithmetic shift. See. After you finish the add, you come here, do the arithmetic shift and then decrement the counter. So let's do the arithmetic shift. So when you do arithmetic shift, keep the most significant bit as it is, 1. Keep the most significant bit as it is and then shift. So this comes here and this bit comes and this bit comes here. And this one goes here and this one and this one and this one. And this 0 goes here. And M, I told you already, do not touch M. So now this is second iteration by the way. Now the count value is decremented to 2. Okay, fine, no problem. Now you go back and check the loop condition. What is the condition? Q0, Q minus 1. Q0, Q minus 1. Now the combination is 1 and 0. So 1 and 0 means you subtract A minus M. Your A is 1, 1, 1, 0. Your m is 1 0 1 1. The 2's complement. When you do the 2's complement, I already did the 2's complement. You take the first complement, you add a 1, you get 0 1 0 1. So I'm going to add it to the A. A is 1 1 1 0. 2's complement of m is 0 1 0 1. When you add them together, add them 1 1 and this is 0 and this is 0 and this is 1. So this is your answer. Can you get the idea? So let me write it. I told you already, when you have a carry, we will be ignoring the carry, is it? So I won't be writing this 1. I will be writing 0 0 1 1 and then q as it is, q minus 1, m as it is. Fine? Is it clear? Why I am writing 0 0 1 1 is, I am getting a carry, I am ignoring the carry. This one we saw in the previous video. When you do addition, you will get a carry. Okay, and you will ignore the carry. We saw it in the previous topic also. So I am ignoring this one, carry bit. And the answer is 0 0 1 1. I am writing it here, A. Write the q and q minus 1 and m as it is. So after this, so I finished with the subtraction. Now arithmetic shift and count. Arithmetic shift. A, q, q minus 1 to the right side. Arithmetic shift. So you keep this 0. You keep this 0 and move it here, and this 0 comes here, this one, and this one goes here, and 1, and this one, and this one, and this one goes here. And m is, as I told you, you don't have to change the m as it is. So what is this? This is iteration 3, and count is now becoming 1. It was 4 and then it became 3, it became 2 and now it is 1. Never mind, we will still continue. Okay then. Now go back to the loop and check the q0, q minus 1. q0, q minus 1. Now it is 1 and 1 combination. The bit combination in 1 and 1. If the combination is 1 and 1 or 0, 0, you don't have to do the addition or subtraction. Nothing. You just straight go here. You do the what is that, arithmetic shift, and decrement the count value. Okay then. So arithmetic shift. So I told you a q, q minus 1 to the right side, and it's arithmetic shift. So this bit comes here. So this 0 you write it, and this 0 comes, another 0, this another 0. This one goes to the q, and this one, and this bit, and this bit. This one goes here. And m is as it is, I told you. This is the 4th iteration, and your count is equal to 0 now. Okay. So now your count is 0. You check the condition. The condition says if count is 0, stop the loop. Mean to say you already got the answer. So you will be finishing the algorithm. So this is the end of your algorithm. So in the end of your algorithm, the answer product you got is A and Q, 0 0 0 0 1 1 1 1. Okay then, so this is the answer. Yeah, here we got the result. The product is, this is the product. The content of A and Q is the product. So this is the answer, which is 0 0 0 0 1 1 1 1. Okay, let's see how do you get, because we are dealing with 2's complement. So your multiplicand is 1 0 1 1, which is minus 5. Your multiplier is 1 1 0 1, which is minus 3. So when you multiply minus 3 and minus 5, the result of this multiplication is 15, and it is positive. Okay, that's the result. You get it. Okay, so this is the positive 15. 1 1 1111 which is the equivalent to 15 in decimal. Okay, so this is the answer. The answer will be in register A and Q. So that is the answer. The 8 bits of the A and Q is your result. Okay, thank you.